How do we build a sustainable city? Urbanization is tied to sustainability. It must be. There are multiple challenges with urbanization, especially in an environment like China with rapid urbanization. So we're going to start drilling down on that topic a little more with the next panel. Let me introduce the participants. We look forward to their conversation. First, the Commissioner from the New York City Environmental Protection, Carter H. Strickland, Jr. Welcome, Carter. And now the Vice President, Executive Vice President from Veolia Water, Jim Good. Jim. The Chief Greening Officer for the U.S. Services Administration, General Services Administration, GSA, Eleni Reed. And the Head of Sustainability Solutions at Autodesk, Emma Stewart. And finally and foremost, our moderator for this panel, the President of Jonathan Rose Companies. Jonathan, welcome. Jonathan Rose himself. Ladies and gentlemen, we look forward to solving the problems in the next 48 minutes.
Thank you. Thank you. Thank you for having us. And thank you all for being here. Okay, our goal in the next 48 minutes is to frame some of the issues about cities and sustainable solutions. So as we just heard from the mayor, the vice mayor of Shenzhen, it was a wonderful speech. Thank you so much for coming. The cities of China are rapidly growing. Actually, there's a funny, which is better, if I do this? Just a second. I'm going to make a sound adjustment here. I think that's better. Is that clearer? Yeah, okay. So we have the rapidly growing cities of China and much of the rest of the developing world. Really extraordinary economic growth. But it really puts on the table for us the issues of the environmental impact. And as we move to a world of 9 billion people, we move to a world of enormous resource constraint. There's also a very large growing middle class. This is the rise of shopping in China. But what we're seeing, this is information from McKinsey, is that today, or in 2007, just before the recession hit, the global population was about 1.5 billion people of those living in the top 600 cities of the world. In 2025, which is not that far away, that's supposed to grow to about 2 billion people. The GDP in these top 600 cities is going to double. And the number of middle class in these cities is just about to double. That's actually very positive for cities, because it is only when you have population growth and economic growth that you actually have the resources to deal with the issues that arise. But the interesting thing is the top 600 cities are going to change. So what we call the developed world today, which is almost an outdated definition, but the United States and Japan and Europe constitute about 380 of those 600 cities. By 2025, that's going to shrink to 250. USA's share of the top 600 cities is going to go from 190 to 125. What does this mean? It means that about 60, 70 American cities are going to fall off the global map. And many new cities, China's working on building 100 eco-cities. Cities in Africa and China and South America are going to rise on the global map of importance. The percentage of the world's GDP that comes from the top 600 cities now, that share is also going to shrink. And so we're going to see a much broader diversification of income from around the world. The question is, as all this prosperity happens, how do we make that sustainable? All right, play the video. I'm going to show a short video. And the first issue is waste. As consumption goes up, waste goes up. This should be moving, but it's not. So as consumption goes, this happens to be the Gramacho garbage dump where our company is working outside of Rio. But as global consumption goes up, waste goes up. We've already heard from the presentation from Japan that we really need to begin to develop systems to use waste as a resource, both as an energy resource, as a material resource, because the Earth simply cannot sustain the degree of mining, material extraction that it's currently undergoing. Let's go back to the PowerPoint. Okay, so we have to begin to think about what's called a circular economy. And each of the presentations you're going to hear that follow me are really going to talk about elements of that. And so if you go to the very top of this, we have mining and materials manufacturing. We're going to need to use recycling to replace that. to substitute, not to fully replace it, but to design our materials so that they can be reused, so that they become an input source into the system. You're going to see product manufacturing. We're going to need to be designing to refurbish, so that not only are we completely taking materials apart, but we're also reusing, and we're designing parts to be refurbished and reusable. We're going to have to, on the retail, service, and sector, we're going to have to talk about collection and redistribution. And then also the use of, there's a behavior element in this, and that is how do we maintain our materials? By the way, how do we keep them for a longer period of time? Since the recession, autos are being held for about 3 or 4 more years in the American economy than they used to be. All these have positive environmental impacts. There's a huge human behavioral element to all this that we actually need to use cognitive and neuroscience to help us design the best behavioral strategies. There are also technological strategies, and we're going to talk a lot about that in the panel coming up. So this happens to be Windhoek, Namibia. This is the first city in the world that began to take its wastewater and reprocess it and turn it into drinking water. It's been running for over 35 years. It's entirely safe. There's never been a health incident. This is an image of the plant. It's an incredibly important as we go to water constraints, and we're going to talk about that more in this panel. We need to think more about the reuse of water. We need to recycle more. So this happens to be, Carter's going to talk in part about this, and this is in San Francisco, has the highest rate of recycling around the country. And the mayor just announced that New York City is going to move to compost recycling. The recycling of organics is part of the linchpin of creating cleaner waste for the rest of the materials, creating biofuels or biogas from the compost that you can use for food. But it's a very critical element of recycling. We need to, so this is actually the recycling facility for San Francisco. And then the last thing we need to talk about is energy. How does energy work? This happens to be the microgrid of Battery Park City. This is during Hurricane Sandy. You see all lower Manhattan lost its power, but Battery Park City kept its power because it was on a separate grid. We need to be thinking about how you create integrated energy and information systems that advance our cities and yet at the same time are able to disconnect when you have major disruptions. And it's clear from climate and from the stresses of growth that we are going to have disruptions in our city. There's that balance, and that balance takes 2 kinds of intelligence. It takes an ongoing systems maintenance operating intelligence, which I know you talked about earlier today on Peter Miskovich's panel, but it also takes a planning intelligence. And so we're going to be discussing that when we hear from Autodesk and how we can really do scenario planning and long-range thinking planning to understand how you can model the stresses that are coming to cities, understand where the pinch points are, and then develop solutions. The last thing is on the building level, we need to develop real green solutions. This happens to be a low-income housing project our firm developed in the South Bronx called Via Verde, very green project, and it integrates not only passive and active solar and other energy strategies, but it looks to build, remember I mentioned earlier behavior, the human community strategy. So it has an orchard built in, it has community gardens built in, performance areas, and a mixture of incomes from low and moderate families together. So we're going to hear from the GSA, which is America's the General Services Administration, which runs the American government's building stock. They're the largest consumer of green building products. They're the largest consumer of green energy services, of green design services in the United States. Really, without the strength of the government, we would not have made the market in the United States that has moved us forward. So that's a framework of what we're going to talk about. And Carter, let's begin.
Sure. Thank you, Jonathan. I don't know if I'll see if I can use this. Well, welcome everybody. This is an important topic. Obviously, we want to make cities enjoyable places to live, and we're happy to serve as a model, but also to learn from other cities. Just a brief, let's see if I get this right. I want to give an overview of who we are, but this is not working. Can you forward it 1 slide, please? See if that works. There we go. Okay. We're working. So I'm the commissioner of our City Department of Environmental Protection. We are municipally owned. We're the largest municipal water and wastewater integrated utility in the country, 6,000 employees, $4 billion budget. We have some basic missions. One is to bring water to cities. You can't have cities without water, and we're lucky to have a watershed of about 2,000 square miles that keeps us as one of the 5 large cities in America. We're one of only 5 that has an unfiltered water source, which is very important, and it comes down by gravity. So right now, we have a very low carbon source of water, which is very important for this. We also treat wastewater, and we have a lot of facilities to do it. I won't dwell on that. We also regulate air emissions, and it's very interesting to see we're almost in 50-year cycles, where in the 1960s, we got rid of coal, at least for heating buildings in the city. And just now, we are getting rid of residual heating oil, which is really a tremendous step forward, and also has not only public health benefits, but also is reducing our greenhouse gas profile even further. Well, here are some of the realities that we have to face. You've heard of the Mayor's Plan NYC Sustainability Report, and really the bedrock of that are climate change predictions that even in the 2020s, which is almost tomorrow if you're building a project today, we're going to see 2 to 3 degree Fahrenheit increases in temperature, precipitation up to 10% more, and sea level rise of 4 to 8 inches. And in the 2050s, which we are planning to, at the high end, perhaps a 31 inch rise, which is very important because a lot of our facilities are on the water's edge. Almost by definition, wastewater treatment plants have to be, and we certainly are planning right now for new construction. We are building at the advisory-based flood maps plus 30 inches to make sure that we are meeting that standard. Well, I'm going to talk about 3 things today and touch on them very lightly, and then we'll have a great panel discussion. I know one is conservation. One is energy and resource recovery at our wastewater treatment plants, and the third is green infrastructure, which is very important. Well, conservation is very important, and we have to ration our supply. It's been a great story at the macro scale in New York City. So the blue line is water use, red line is population. We have this decline. Here we are. The current figure is actually about 8.3 million. We're going to add 1 million more people by 2030. But we peaked in about 1980 at 1.5 billion gallons a day. Since then, we've been able to reduce that by 50%, which is pretty remarkable. And this is something that is going to have to be replicated around the world. The UN estimates that by 2030, more than half the world's population will live in water-scarce areas. And that, by the way, includes a lot of the US. Texas is in the midst of a 3 to 4 year drought. They're locked in, as is Denver and other places that are high growth measures. And in fact, cities have taken, if they can afford it, have taken drastic measures. In 2008, a drought forced Barcelona to order 6 ships of water a month, delivering more than 400 million gallons. Of course, that came at a cost of, each per gallon of water was 3 times the normal cost of water. It's not very sustainable financially and is not a good solution. Well, one of the solutions, of course, is decreasing consumption. So compared to where we were on a per capita basis in the 1970s, where the average New Yorker was consuming about 220 gallons per day, we're averaging about 125 gallons per day, which is still a lot, but the good news is in new construction, where we have new construction standards, new appliances, new fixtures, and the like, we're at about 50 to 70 gallons per day. It again is high by standards elsewhere in the world, but the aggregate drop of 1.5 billion gallons a day to 1 billion gallons a day is very considerable. How are we doing it? Number of measures. One, of course, is my favorite is just replacing toilets. If you go back, actually, we started this drop. It was really precipitated by the start of metering. We didn't really meter that universally. We charged by what is called the frontage rate, a very quaint formula. We estimated the number of fixtures, length of your building, and charged you. Well, now we meter by consumption. That's how we bill. It's a volumetric bill. It has a built-in incentive to conserve water. The more you conserve, the lower your bill is. So metering happened here, and you can see the decline. And right about here, we had a toilet replacement program where we paid for the replacement of 1.3 million toilets in New York City. And the reason that makes a difference is we went from about 5 gallons per flush, 7 gallons, some of the older toilets, to a very low number, and believe me, that adds up. shower and toilet usage is a high percentage of what we do. How else are we getting there through conservation? Well, I mentioned metering, but we're actually taking it to the next generation of metering. We have what are called automatic meter readers, which will take the meter charge, put it to our central computers 4 times a day, so you as a consumer can go online. It's not quite real-time price signals, but we're getting there, and you can track your usage. It allows you to sign up for a leak notification program and the like. So as we educate people, also through things like benchmarking buildings on a building-wide basis, people will start to realize, hey, I use this much water, I can reduce it. I mentioned conservation pricing, and we also have a municipal water efficiency program working with park schools and city-owned buildings to reduce our water, which we think is very important. And there's a lot of reasons for that. One reason is that we're repairing our Delaware aqueduct, and we're going to have to, for about 6 to 9 months, be without our prime source of water. But here's another reason, is that water, I had mentioned that as a gravity-fed system, very low carbon footprint for our water supply. That's changing. And it's changing because here we are today, but we're building, this year, we're putting on a line, the Croton filtration plant. We do have to filter now our water from our old system built in the 1800s on the east side of the Hudson because that watershed was developed. We're also putting online a UV treatment facility, which is a regulatory requirement, obviously uses a lot of electricity. Our electricity use is going to go up 46%. Obviously, the less we use, the less water we have to treat on the front end, the less water we have to, wastewater we have to treat on the back end. That is very important. So we're managing demand, as I mentioned, but we're also managing supply. This is a picture of the digester eggs on the upper left at Newtown Creek. These take the solids that are left over in wastewater and basically digest it in an anaerobic environment. It produces methane. We now have projects on the books to sell that gas. We use a lot of gas at our facilities and recover that energy, but we also have plans to work with National Grid to put it into the grid and power about the equivalent of 2,500 homes, which will reduce 15,000 metric tons of greenhouse gases per year. We have upstate hydroelectric plant projects going on. There are 4 active hydroelectric facilities in our supply system now. We're going to develop hydroelectric facilities at 3 more dams in our watershed, and that will yield up to 16 megawatts of clean energy. Solar panels, we now have a public-private partnership at one of our waste treatment plants, 200,000 square feet of PV on a rooftop, and that's going to generate up to 1.6 million kilowatts a year, or about 10% of the plant's annual charge. And finally, we are working on the next generation of recovering that embedded energy in the solid waste stream portion of the city that you might not think about, which is sewage, and to actually produce electricity through cogeneration. And we have at our North River plant a project that by 2019 will produce up to 12 megawatts of energy at the plant, saving us $5.6 million a year in energy costs. Continuing the theme of recovering resources from what had heretofore been considered waste, we often think in precipitation in the city that rainfall is essentially wasted, and not only that, can generate pollution because it can lead in our system to combined sewer overflows, our biggest water quality issue. Well, if we reconceive of that rainfall as a resource that can support plant life, we can beautify the city and also manage waste in a less costly way than we have before. We have some experience I mentioned in our watershed of using natural forests to clean our water. That does reduce our costs. In city, this is an example of a blue belt. Looks beautiful, raises property values. People want us to build these, but it's very engineered. This is not a natural curve that's engineered by us to slow down the water, filter out pollutants on its way to the sea. So that is what we're doing with stormwater. But what you need to conceive of is a network of what we call green infrastructure to distinguish it from gray, meaning concrete, This green infrastructure is working infrastructure. It just happens to be plants and the like, very self-sustaining. If we have a network of these bioswales, curb cuts, water will go in, it will not get to our sewer system. Look at how it beautifies and works in synergy with this bike corridor, beautifies the neighborhood, provides shade, cools the city. So we think this is a solution that makes sense economically, and a number of cities are adopting this as their way to comply with pollution control laws. With that, Jonathan, those are our 3 ideas.
Thank you. Wonderful. Really, it's great to be part of a city that's moving forward so well. Jim, talk to us about what you're doing in Pittsburgh and Paris and around the world.
All right, thank you. Thank you for the invitation and having me here. And our slides might be out of order, it appears.
GSA. There you should go.
I can go.
But that reminds me of coming into the city this morning, and I realized my topic was sustainability, and coming in a New York City cab and seeing the reaction that cab driver got from pedestrians and cyclists, I can see that the supply of the New York bird is sustainable and certainly not about to decline anytime soon. I'm with Veolia Water. We're the world's largest water services provider. We're part of a larger global company called Veolia Environment, headquartered in Paris. I currently am serving on a consulting basis as the general manager of the Pittsburgh Water and Sewer Authority. And you can see there a picture of beautiful downtown Pittsburgh, the second greatest city in America. And when our chair brought us together a couple weeks ago, he asked us to find some specific examples to talk about related to sustainability, which was quite difficult because our company really has pioneered the way in finding sustainable solutions and working with municipal and industrial clients to implement them, and in things such as having performance-based contracts to require environmental compliance under our contracts imposed on us, and on, for example, the industrial side, resource recovery through the processes of treating water and treating wastewater. And so I did narrow it down to three cities and 3 subjects. And the first may not seem quite related to sustainability in the traditional sense, but it's probably the thing I worry about more than anything else. And the thing that keeps me up most at night is just in general, where am I going to get money to do meet environmental requirements and for example, fund sustainability efforts, even if they have a present value benefit or a triple bottom line benefit. The question of where I'm going to get the capital to do these projects is one that I think any municipal manager struggles with on a daily basis. Nobody has figured this one out.
A little shake.
No?
Ooh.
That was not the right button.
So, AV guy, can you go to the next slide?
Thank you.
There we go.
All right, so I wanted to talk about something very specific that we're doing in Pittsburgh. We're consulting to that city under what we call our peer performance solutions, where we bring in folks from literally all around the world to work with the city to identify additional revenues. If you could hit the button again.
It's the next slide.
The next slide. Well, if you go forward. There you go. In just 11 months we've been there, and Pittsburgh is very small. It's only a 300,000 person city, which most people are surprised of. I know I certainly was. But in less than 11 months, we've identified 1.3 million in additional revenue. And next slide. 1.2 million in savings. Not a whole lot of money, although it's about 2.5% of our operating revenue. We've done that without raising rates or laying anyone off. Next slide, please. And one more. This was all going to be really cool and fancy and everything, but was that you? Okay, thank you. That's why I keep getting promoted. I can't do anything. The benefit per person is quite small. It's $16 per average residential customer bill, which is not a whole lot of money. I mean, you can't really do much with $16 a month. But if you multiply that times our customer base, what that means is we can issue $20 million in new debt financing, essentially, without raising rates or cutting employees. And so that's a significant source of new money that enables us to meet our environmental mandates and embark on sustainable programs. And we are embarking on quite a green effort in Pittsburgh, although it's in its very early stages, and so I have nothing definitive to provide you on it at this point. However, I do have, as being from a French company, we have to talk about Paris. So those of you who've been to Paris or not, you'll recognize the general outline there. In the upper left-hand corner, the northwest corner, you'll see some arrows pointing to it's a neighborhood. It's been a long time since I studied French, but Clichy-Batignolles. And what I'm just going to call it Clichy because it's easier for me to pronounce. Clichy is an old rail yard on the very outskirts of Paris, as you can see, that's being redeveloped into a mixed-use development, residential, a business, some transit stations, about 133 acres, 25 acres of which is a park, interestingly named the Martin Luther King Park. And this is a conscious approach by the city of Paris to increase the density within the city boundaries, but without affecting those parts of Paris that when we go there we all visit, which is the parts really in white, sometimes referred to as the Belle Époque. It's the part where all the tourists go. Paris wants to integrate itself with the suburbs, the city's population of 2 million, the region's 12 million, so they're starting to do this with these redevelopment projects. These projects are sustainable with a heavy focus on green. In terms of green infrastructure on the water side, they have a goal of retaining, it doesn't translate great from metric to English, but 55% of the first 2/3 of an inch of every rainfall they want to retain on site. There's similar standards like that in the United States, and the essence is that the so-called first flush of a rain is usually washing out, say, motor oil from the sidewalk, what have you, pesticides, and you don't want that to go into your water supply or your river. It also helps reduce combined sewer overflows. We do that, and this is a project where we design the green infrastructure, that all roofs in the development, depending on their thickness, have to retain 50 to 85% of the 2/3 of an inch. The green space, swales, some of the tree boxes that you saw in Carter's slides need to retain 100% of that standard, and rainwater harvesting, where you actually take the rainfall and use it for example, applying to your garden, the 65% of the retention. So that's a real project that's in place. People are moving in, and it's been quite a big success in Paris. We're pleased to be part of it. Finally, I wanted to talk about sort of the network effect that Veolia is able to bring and tie it back to sustainability. You'll see here on this map a reference to Vancouver. That's Vancouver, Washington, not Vancouver, British Columbia. It's across the river from Portland, Oregon. It's Portland's Brooklyn. It has a population of about 150,000. And from that, we actually operate two other systems within the state of Washington. The Cascade Water Alliance is essentially a reservoir near the city of Seattle that we operate. And Cle Elum, those of you who watch Northern Exposure, the opening scenes were filmed there. It's a town of about 2,000, about 300 miles from Vancouver. Because of our resources in Vancouver, where we have over 50 people, we're able to essentially operate those other two facilities, in the case of Cascade with 5 staff, in the case of Cle Elum with 2. These are reductions of between 30 and 50% because we can back them up with the resources from Vancouver. Now, how does that apply to sustainability? You say, well, if you look at the requirements that apply to a water system or a wastewater system, whether they're existing discharge requirements or future needs, they're all the same. They're the same for Little Cle Elum of 2,000 people as they are for New York City. And they require the same level of technical expertise and knowledge. We can provide that through our Vancouver operation without imposing an impossible financial burden on a little town like the city of Cle Elum. Furthermore, One of the things that we've done in Vancouver we're extremely proud of has been our reduction in energy consumption and greenhouse gases. That's very routine anymore, but the thing you have to remember about Vancouver is they get hydropower. So hydropower costs 5 to 6 cents a kilowatt hour. I don't know what you pay in New York. It's probably 20 cents a kilowatt hour or something like that. But the comparison, it gives you an idea. But through our experts, for example, in New Hampshire, we have our leading energy efficiency expert in North America. And then in Paris, we have a research facility with literally hundreds of people. We were able to bring these folks in to introduce the best, newest technology in various variable speed drills, the use of a fluidized bed incinerator, which basically is a way to incinerate sludge, and to do it in a way that reduces both the cost of power and the usage of power. And in both of those cases, despite the low cost, because all of these things require an investment that has to pay back, we've been able to reduce power consumption and greenhouse gases in Vancouver by 20% by virtue of our network across North America and across the globe. So with that, I'll turn it over to our next speaker.
Thank you, Jim.
Is it the second button?
It's this button right here.
One of the advantages of being a third speaker. Good afternoon. I wanted to talk a bit about what the U.S. General Services Administration is doing to reduce the environmental footprint of its real estate portfolio. So I will just start the conversation by telling you a bit about GSA. I work in the real estate arm of GSA, which means that we're the federal landlord for civilian agencies. Overall, the portfolio is about 376 million square feet with buildings all across the US. And we manage, operate, design and construct and dispose of properties. So we touch all phases of the real estate life cycle. About half of our square footage is in owned buildings. The other half is leases that are held in the private sector. And one of the things that GSA has been focused on over the last 30 years is providing efficient, cost-effective, and sustainable spaces for workers in the federal government. We have a number of targets that we are mandated to achieve. As you can imagine, there's a lot of legislation that directs our sustainability efforts. We have targets for just about everything you can imagine around environmental performance. We have energy use intensity targets, water intensity, greenhouse gas emissions reductions, diversion of C&D waste, diversion of municipal solid waste, and we also have renewable energy targets. So our efforts have been occurring over the last 30 years. I would say that there was a renewed emphasis on this with the passing of Executive Order 13514 back in 2009 that really highlighted the federal leadership in economic, energy, and environmental performance. So with that executive order, all federal agencies were mandated to develop a sustainability plan, which we have to renew on an annual basis. We report on our achievements on an annual basis. And we also were asked, each federal agency was asked to define their greenhouse gas emissions reduction targets, both for direct and indirect emissions. So we've utilized a number of strategies to achieve our goals, and I'll be touching on some of them today. What I wanted to highlight as well is some of our accomplishments. You can see this is an example of a scorecard that each agency submits to the Office of Management and Budget on an annual basis. And it shows that overall for GSA, and this is our scorecard for the past fiscal year, we are on track and in some instances surpassing our annual targets, and we're on track to meet our various environmental objectives. Each year it gets a bit more difficult as the low-hanging fruit is accomplished, and we look to achieve the higher level of savings that we're tasked to do, not only to make our buildings more sustainable, but also to be more cost effective. I want to touch on now on a couple of examples. We were fortunate enough back in 2009, and it appears now that it's a very different era. In 2009, there was the American Reinvestment Act, which allocated funding to federal agencies GSA received at that point in time $5 billion, and it was used to reinvest in the buildings portfolio to transform some of our assets that were in need of repair into higher performing buildings and to create jobs. So I'm going to show a few examples of what we were able to achieve on a couple of projects that are nearing completion. I also want to touch on the fact that now we're in a completely different budget scenario, and as was mentioned earlier, we need to find alternative financing strategies, different ways of funding our projects. So I'll touch on that as well. And then I'll also talk about how we're looking at portfolio-wide strategies to achieve some of our targets. So first I wanted to talk about a couple of examples funded through recovery that are just coming online. We have predicted that the investment in recovery dollars across 450 properties in GSA's inventory will yield something in the vicinity of an 18% energy use reduction over the baseline. So the first example I wanted to show is a historic property. 25% of GSA's portfolio is considered historic. We have a number of 19th century and early 20th century buildings in the portfolio. Some of these were recipients of Recovery Act funding. This is an example of one of the flagship projects. It's a courthouse in Grand Junction, Colorado. And in that building, we were able to design it to be site net zero energy. And a variety of strategies were utilized to design to that intent. And it will also potentially be the first property to meet that achievement on the National Register. So there are a number of benefits, of course, in working with these buildings. That particular type of building is inherently better constructed. There are passive strategies that are already in place. And so for this particular building, the utilization of both geothermal and solar panels were able to get us to this design to site net zero. Another example of how GSA looked at reinvesting is redevelopment. This is an example of a project that was recently opened in Seattle, the Federal Center South complex. It was a site that was redeveloped, formerly a brownfield site, into the headquarters for the Army Corps of Engineers. There are a number of interesting features with this particular project that I wanted to highlight. A number of high performance features, of course. We're looking at a building that's going to be performing probably about 40% over ASHRAE. One of the interesting things too with this project was the delivery model. It was a design-build project, and the GSA, working with the A&E firms, looked at the design-build model and was looking at a performance contract approach where we have retained 5% of the total fee to the end of the project to make sure that the energy modeling and the energy reduction that was anticipated after 12 months of operation is actually delivered. So that was a first for GSA, and it is also being something we are looking at for another project at the moment. Another example are mid-century buildings. We have a number of those buildings in our portfolio. Approximately a third are built in that era. A number of issues related to that type of building. Construction in those days happened quickly. Materials not so durable. They present an enormous challenge. So this is an example of a project that was recently completed in Portland, the Edith Green Wendell Wyatt facility. And the photo is showing here what the strategies for envelope. A number of strategies were also implemented to have renewable energy. So there's a solar array on the rooftop, also looking at collecting stormwater. And as you can see, the project is shooting for significant energy efficiency and reductions of potable water use. I was saying also that we're facing a completely different scenario, whereas there was considerable investment available to us back in 2009, budgets have been drastically cut. And so for major retrofits at the moment, we are looking at alternative financing. The there's a presidential memorandum that was issued back in 2009 requesting that federal agencies look at energy savings performance contracts to get to energy retrofits and to uncover energy conservation measures. So each agency is tasked with bringing energy performance contracts, working with ESCOs to achieve retrofits. So GSA at the moment is involved in a number of ESPC projects nationally with a goal of increasing the energy savings that are traditionally derived from ESPC projects. Traditionally, the federal government has achieved 18% with ESPC projects, and our goal is really to, in working closely with the ESCOs, to augment the energy savings that we can obtain. There are also a number of portfolio level strategies that we're implementing. We're leveraging technology and some of this was discussed earlier in terms of having readily access to data, how that informs building operators and how we can then transform that information to run buildings more effectively. And I wanted to touch on the linchpin of a number of strategies that we're utilizing. So advanced metering is something that GSA started on a few years back. We were able to invest more significantly in smart meters with Recovery Act funding. So we now have close to, or will shortly have about 400 buildings that have smart meters installed, and that will represent about 80% of the agency's electricity consumption. Not only do we have meters for electricity, but we also are installing them for water. And a couple of examples here on the slide show how building operators are utilizing this real-time information at 15-minute intervals. So the examples show how, for instance, the first example is energy use reduction. The BAS was showing that on the day that the building was supposed to be closed, the systems were still running, and how with this information we were able to close the systems for a future holiday. The second example is a water use example where a leak was uncovered, and we were able to then reduce the leakage and therefore save water. So advanced metering is a linchpin, I was saying, to a couple of initiatives. One of the things we're doing we are required to do energy audits every 4 years for a percentage of the buildings that are deemed the most energy intensive. And we have uncovered a cost-effective method of doing energy audits that is done entirely remotely, rapid building assessments. So with the data that is provided through smart meters and information, GIS information and weather information, working with our provider with analytics, we are able to uncover performance and ECMs. And this approach we're just starting with this, and we have done this on 25 buildings at the moment, and we're finding that this method is as effective as on-site audits. It's probably equivalent to an ASHRAE Level 2 audit. The other strategy that we're utilizing is smart buildings, again, with the fact that we have advanced meters installed in a number of buildings. We're looking at technology. How can we leverage building information, building management information, put that onto a single IT backbone, and have all the information connected? At the moment, we've started with 50 buildings. All the information goes back to a sustainability center, and then we're able to use the plan is to use the information to identify faults and then provide the information back, or even automate some of the processes. So we're just at the beginning of our smart buildings initiatives. This has been something that's been in the works for the past, I would say, 2 to 3 years. We're finally looking at the first 50 buildings, and the strategy was developed around 3 pillars: buildings, people, and technology. So we're leveraging the technology, transferring the information to the building operators, automating the processes where possible, and then engaging the building occupants as well, providing information on building use and hoping to influence behavior and engaging them on, in this case, energy use. The other thing we're trying to do, and I think just at the beginning of this, is to provide real-time information to building occupants. The example on the left is a video wall that has been mounted in one of the facilities in San Francisco. It provides information to occupants on a variety of things, including energy. And the vision on the right-hand side is something we might be able to see in the near future with the buildings that are part of the Smart Building Initiative with our GSA Link initiative. So building occupants would find, as they enter the building, real-time information on energy use in that particular building. We're not there yet. It's obviously something we're looking to do, and it connects well with the Smart Building Initiative. The other piece I wanted to talk about, again, is about technology. There'd been, and this was mentioned earlier, there's so many changes happening in the market with whether it be material science or building or IT solutions. What are the solutions out there that we could use most effectively to help us accelerate our sustainability objectives? So what we did 2 years ago was to create a program called the Green Proving Ground, which is a testing and evaluation program. We look at what new technologies are out there. We are looking to test them in a buildings operation environment, install them in 1 or 2 buildings, perhaps different building typologies, different climate zones, and uncover whether these new solutions are something that GSA might be interested in implementing in more buildings. So the premise here is to identify solutions that might exist in the marketplace, test and evaluate them in collaboration with the Department of Energy National Lab, study, are they performing true to their specification? Are they cost effective? How are the occupants interfacing with that particular technology? And what is the potential of that technology to help us with energy or water use reduction across the portfolio? So is there, for instance, a deployment strategy? Should we be implementing them in multiple buildings? Is it only a technology that we should be looking at installing in certain building types or certain regions? And we've issued a number of reports, and I provided the information here. So we're uncovering solutions that are things that we will be looking at in the future. We're currently looking at how we deploy once we find a solution that is cost effective and that we are looking to implement in more buildings. So with that, I will pass it on to Emma.
Good afternoon. My name is Emma Stewart. I direct the Sustainability Solutions Group at Autodesk. And there I am charged with incubating new design software that addresses the energy, water, and materials related challenges in the buildings, infrastructure, and manufacturing sectors. But this afternoon I want to start by talking about what my daughter has taught me about the future of cities. And that's because my daughter is an urban kid through and through. She was born in a hospital on a hill overlooking the city's skyline. She has a library down the block, 3 parks within a 10-minute walk, and dozens accessible by bus or by light rail. She has playdates with 3 other families on our block and makes regular appearances at the weekly farmers market, science museum, and local pool. The car is foreign and boring to her. She is one of 3 billion urbanites, which will be 4 to 5 billion urbanites by the time she's my age. So, as you've heard, these new centers of humankind represent the majority of the world's GDP, its resource consumption, and its waste production. In the petri dish of Earth, they are the dense clusters of life, growing organically atop a global culture. But by 2050, these cities will have either reinvented themselves or burst at the seams. If we play our cards right, the 2050 city will recognize its context, situated within a natural and agricultural ecosystem that provides its denizens with abundant raw materials, free crop pollination, and genetic diversity. The 2050 city will be resilient, responding to long-term shifts through adaptive reuse and short-term shocks through high-tech smart devices and low-tech biomimetic designs. The 2050 city will be water neutral, drawing from its aquifers only as much as it can recharge, and the rest from the sky or recyclers that will then be part of basic plumbing. The 2050 city will rely so heavily on efficient building design, decentralized generation, district energy systems, and multimodal transit that its citizens will emit no more than 1 ton of greenhouse gases per person per year. So how do we get from here to there? I won't pretend that urban redesign is straightforward. As you've seen here, it requires conceptualizing within the constraints of existing developments, tending to the often competing needs of various stakeholders, convincing the citizenry to vote with their pocketbooks for new financing, and accomplishing large-scale projects on a time frame that keep the city and its resident industries competitive for both taxes and talent. All of these challenges will still exist when my daughter is an adult. So what will be different? The one thing I can bet on with absolute certainty is that before she knows how to drive, how to vote, or how to pay taxes, she'll be able to simulate her city on a computer. As we'll see in the video, we are working with cities around the world on what this might look like. Since buildings typically account for the majority of end-use energy, she may first, press play please. Great, thanks. She may first want to determine which of the city's buildings shown here are suitable for energy retrofits, perhaps a cool roof program to reduce cooling loads. She can analyze the roof types to exclude complex or pitched roofs or those who have perhaps already committed their roof space to other functions. She can also consider where rooftop photovoltaics make sense based on sun insolation values embedded in the software. And to understand daylighting, the program tells her where the sun and its shadows will be at every hour of every day of every year. She might then connect to an economic calculator shown here to determine whether PV panels make better economic sense than roof whitening in this district. Second, as most cities are contending with increasingly frequent and severe storms alongside already overburdened stormwater and wastewater systems, she'll then use the tools shown here to increase the relative amount of permeable versus impermeable surface, just as an urban hydrologist would, but without all of the expertise required. By using conceptual design, really sketching tools, within the context of the existing environment, which has been imported through laser scanning or GIS maps, she'll be better able to explore designs which embrace low-impact development techniques. She can look at the hydraulic effects of green stormwater infrastructure in an attempt to avoid the need for yet another costly wastewater treatment plant. And data within the model will allow her to compare her conceptual sketch with reality for permeability, for impermeability, the effects of rain gardens, bioswales, green roofs, and the like. She might move on to tackle transportation, especially since congestion is so costly to cities both in productivity and emissions. Our customer, shown here, the City of Vancouver, has built a simulated version of their entire city by combining terrain files, building footprints, satellite photos, and GIS data for parcels and streets into a 3D modeling program. These simulations are becoming even more affordable and accessible now that they're running in the cloud and not on the desktop. And together we'll be able to see how their stormwater system could be improved, or their energy efficiency incentives better targeted. So why are we using techniques from the 1800s, like dams, levees, and clipboards, when we have technology from the 21st century, like 3D modeling, simulation, and cloud computing? My daughter, your children, and their 5 million future urbanite friends would happily give this a try. And I think we owe them as much. Thank you.
Are we done, or can we take a question? Any questions from the audience?
Good.
Good, then I think we're all done. We're running a little bit behind schedule. Great. Thank you all very much.
Thank you.